Carbon compounds rule the globe. They are present in almost all bits and pieces that we can see, touch or smell. However, when we say hydrocarbons, what does it exactly mean? Yes, in literal terms, we mean compounds made up of carbon and hydrogen. But tell me one thing, are all the carbon compounds only made up of carbon and hydrogen? Are there no other atoms that make up the compounds? If all the compounds will have only hydrogen and carbon, then every compound should have the same or similar properties, right? But that does not happen. We see a wide variety of properties in the carbon compounds because elements other than carbon and hydrogen can also be present in them. This gets us to the concept of functional groups. Now, what could this mean? Let us understand this concept in a simple manner by splitting the terms. The word groups means a collection. That indicates a collection of atoms. And functional means having an important role or function. This tells us that the functional group is a group of atoms that have an extremely important role in the functionality of the compound that they are present in. Yes, say there is a random compound WXYZ which is attached to the functional group AB. In this case, the properties of this entire compound are majorly determined by the functional group AB. There is another way in which we can understand functional groups. They are defined as the groups of atoms which have definite properties. These functional groups impact the properties to the compound in which they are present. The presence of functional groups defines the properties irrespective of the length of the principal chain of carbon or side chains attached to it. Do we know a few examples of functional groups? Of course we do. You must have come across the terms alcohols, aldehydes, ketones, phenols, and so on. These are nothing but functional groups. So let us say we take a carbon chain of 10 carbon units. The carbon chain may be straight chain or a branched one. Say it has an alcoholic functional group attached to it. This was the case of saturated hydrocarbons. Same holds true for unsaturated hydrocarbons as well. Now, in any case, the properties of the compound formed will depend on two factors. First factor is the presence or absence of a single, double, or triple covalent bonds between the carbon atoms. It means the compound being saturated or unsaturated will define many of its reactions. Another important influencing factor is the presence of a functional group. It is this group that gives the characteristic properties to the compound formed. Now let us have a look at a few more examples of functional groups along with their structures in the upcoming videos.